Hello everyone, let's solve some Leetcode today. So today we have Leetcode 88, that is merge sorted array. In this problem we have been given two integer arrays, that is nums1 and nums2, and both of them are sorted arrays. They are sorted in ascending order or non-decreasing order. And we are also given two integers m and n. They represent the number of elements which are present in nums1 and nums2 respectively. Now we have to merge the nums1 and nums2 array into a single array, and that single array should be sorted also. One catch is that we are not supposed to return any array from the function itself. What it means is that we need to make in-place modification in the nums1 array. So nums1 array will have extra space m plus n so that we can accommodate the elements from the other array into the nums1. So as you can see here that we have a few elements 1, 2 and 3 in the nums1 array, and then these elements are basically representing the empty space that we can use to actually accommodate the elements from nums2 array. So it means the empty space will be equal to the length of the nums2 array, which is given by this particular integer n. So we have to figure out how to merge these elements and then these elements into this single array nums1, and this array should also be sorted at the end. So one straightforward way is to actually take all these elements and then just put them here. So nums1 will become this 1, 2, 3, 2, 5, 6. And now that we have all the elements inside of a single array, we can simply sort them. And then the array will become 1, 2, 2, 3, 5 and 6. This is sorted array and we have all the elements from nums1 and nums2. But here's the catch. This is not an optimal solution. Why? Because sorting itself will take order of n log n. So this solution right now is n log n because of sorting. And there is a way to do better. We can actually bring down the time complexity to order of n. So we can use the same technique that we use in the merge sort. So in merge sort, when we actually have two sorted arrays, we compare their first elements and then see which one is smaller. Whichever is smaller, we take that and we put it in the array, and then we shift the pointer to the next one here, and then we compare which one is smaller. This is smaller or this one is smaller. Whichever is smaller, we take that one and then we shift the pointer again, and then we again check which one is smaller. Here it is 2, and then we actually shift the pointer and then we check again which one is smaller, this or this. Clearly this. Now pointer goes here. We have exhausted all the elements in the nums1 array, and so we will put all these elements remaining from the nums2 into the answers. But the issue here is that we cannot really do it this way. We can use the same way, but not this way, because we are supposed to modify this nums1 array itself. We are not supposed to create a new array. This will work in the case of new array, but right now we are supposed to make changes in this array itself. And if we try to do it this way, we have 1 here and we have 2 here. Which one is smaller? Clearly 1 is smaller, so we will let it be. Then we will shift the pointer in this place. Then which one is smaller? Is this smaller or is this smaller? Doesn't matter. 2 is the 2. Then we will again shift the pointer here. Which one is smaller? Is this smaller or is this smaller? Clearly this one is smaller. So we will have to take this 2 particularly and put it here in this array. Now where do we put it? Clearly in this particular place. So we will have to remove the 3 and then we will have to place the 2 here. Now here's the problem. Where is 3 now? Because we still need 3, right? 3 needs to be part of this nums1 array somewhere. Now some of you may say that okay, just shift the 3 to this place. Right now in this example it works because it is 0 here. But what if there are more elements? What if there is a 4 element? So what do you do now? Do you take all these elements and then shift them by 1? That itself will take order of n. Shifting itself will take order of n, and you are already running an order of n loop, so it will just combine to order of n square eventually. So that is clearly not a good way to do this. And the reason we are suffering this problem is because there can be other elements in this side also. It's not just 3. So where do we keep the 3? How do we keep track of the 3, right? That is the issue that we are facing. And there is an elegant way to solve this problem. Instead of starting from the start of both the arrays, why don't we start from the end? So we will have a pointer at the last element in nums1, and then we will have a pointer at last element in nums2, and then we will have a pointer at last element, completely last element in nums1. So this pointer signifies the place where the elements in the nums1 ends, and this pointer signifies the total capacity of nums1. So what we can do is now we can check, is this element greater than this? Clearly not. 6 is greater than this. So what we will do is we will store the 6 here, and then we will shift this b pointer to this particular place. So b will be here now, and c will need to be shifted too because we have already filled this particular position. So c will come here, and now we check, is this bigger than this? Well, clearly not. 5 is greater than 3. So we will put 5 at this place, and then we will again shift the b to this particular place. Now b is here. We will also shift the c to this particular place. So c is here, and now we will check which one is bigger. So clearly 3 is bigger. 3 will be placed here, and at this point a will be shifted to here, and now the c will shift to this place, which is okay because this place right now we have already dealt with. We have placed this 3 in its proper place here. So we don't need to worry about this place getting overwritten at this point. Now we will check which one is bigger, this or this. Clearly they are both equal, so it doesn't matter. We will just put 2 here and then we can shift any pointer. So suppose I shift this one and now I'm out of bound. So it means I need to stop my loop, I need to stop my algorithm. And now look at the state of this particular array. It is now 1, 2, 2, 3, 5, 6. It is sorted and we have merged both the arrays into a single one. So this is an elegant way to use the same merge sort technique just in the reverse order. Because in the reverse order we were always able to handle the elements and their position before ever reaching them in the nums1. That's why it was fine to override this 3 here with 2 because we already handled the 3 in this position, and this will always be the case. Now here is another edge case. Here we have our C pointer, A pointer and B pointer at the correct places, and now let us try to do the same thing here. We check, is 6 greater than 5? Yes, 6 is greater than 5, so we will put it here. Then we will shift the pointer, C will come here, then A will be here, and now we will check again. Is 4 greater than 5? No, 4 is not greater than 5, so it means we will put 5 here. We will shift the C to this position, and then we will shift the B to this position. And now we will check again. Is 4 greater than 3? Yes, 4 is greater than 3, so we will put the 4 in this position. C will be shifted here, and the A will be shifted here. Now A is out of bound. We have gone through all the elements in nums1. It means we need to stop the loop. So we will stop the loop, but at this point you can see that these elements are still in the nums2 which have not been merged in nums1. We know that C is here in nums1, and we know that all these elements are completely in sorted order, and these elements are greater than these elements for sure because we have sorted them. And these elements themselves are sorted, right? 1, 2, 3. So all we have to do is put them as is inside of this nums1 array. So we will simply override elements in nums1 from here to here. So we will take the 3, we will put it directly here in the C position, we will shift it, C will be here, then we will take the 2, we will put it here in this position, then the C will shift again, and then we will take the 1, we will directly put it here, and our list is completely merged now. Of course, this B will be used to keep track from where do we need to merge. We are not supposed to merge from 5, right? So this B pointer will also keep on shifting as we merge. So at the end, B will be here and C will be here. And then we have a completely merged and sorted array. Now let us go through the code. We have A is equals to m minus 1 because m represents the number of elements in nums1. Then we have B is equals to n minus 1 because n represents the number of elements in nums2. And then we have C is equals to length of nums1 minus 1. So it means we are setting that C to the last index of the entire nums1 array. And then we run the loop. So while our A pointer and B pointer, both of them are greater than or equal to 0. It means both of them are within the bounds. They are not out of bounds. We check if the current element at nums1 is greater than the current element at nums2. If it is greater, we take that element at nums1 and put it at the C position in the nums1 itself, and then we simply shift the A pointer to A minus 1. Otherwise, we take the element in nums2 and then put it in the C position at nums1, and we shift the B pointer to B minus 1. And at the end, we are sure that we have placed something at the C position, so we will also shift the C pointer to C minus 1. Now after this loop runs, we have two situations. We may have run out of nums1 array, or we may have run out of nums2 array. If we have run out of nums2 array element, we know it is fine because there is no element left to be merged. But if we ran out of the elements from nums1 array first, we know that there are still some elements in the nums2 array that needs to be merged. We are talking about this particular case where we just ran out of nums1 first and we still had elements in the nums2 array. So we will simply run a while loop to put all the remaining elements from the nums2 array into nums1. So while b is greater than or equal to 0, we are taking the elements from the nums2 and putting them in the nums1 at C position, and then we are updating the b variable and C variable. And in case we ran out of the nums2 elements, we know that the b will be less than 0 at this position, so this while loop will never run in that case. So that means it will only run if there are still some elements in the nums2 array that needs to be merged. So yeah, we are done with the code and we are not returning anything because we are changing the nums1 array in place, and that is what will be checked by the online judge. So now let us run it and see what happens. So yeah, it runs in 0 milliseconds and beats 100% of the solutions on Leetcode. This number is definitely not trustable, to be honest, but now let us look at the time and space complexity of this solution. Here the time complexity is order of m plus n, and that is because m plus n represents the total number of elements that we had to traverse. You can also think of it this way: m plus n represents the total length of the nums1 array, and we are supposed to traverse the entire nums1 array, right? So it means our while loop will be running m plus n times to go through the entire nums1 array. And so in that way also you can understand that the time complexity is going to be order of m plus n. Now the space complexity is going to be order of 1 because we only have 3 variables, a, b and c. That's it. These variables themselves consume only a constant amount of space, and this space does not depend on the size of the input. So we can have millions and millions millions and millions of elements in the array, and that would still not change the space consumed by these three variables. They will be same, and that's why the space complexity is constant or order of 1. So yeah, like the video, subscribe the channel. If you have some kind of question that you would like me to target, or you have some kind of topic that you would like me to talk about, then just let me know in the comments. Now we will meet in the next video. Till then, bye.